So our chapter is about environment chemistry. All we're gonna read in this chapter are two basic topics. So everything is general knowledge. Might be little bit of chemistry you'll study, but if your general knowledge is clear, you should be okay with this chapter. We're gonna study about two aspects: water and air, and everything that causes or deteriorates the quality of water and air. Why are they important for us? I think from childhood we are learning why are they important for us. What is the way that we get as a natural resource? Is the natural resource directly consumable by us? If not, what? So that is what we are going to study, right? First section of the chapter will concentrate on water. Today we'll talk about water, and one of the sources of water pollution is also fertilizers. So we'll talk about fertilizers. Our target is to finish water and fertilizer today, and in the next class we will be finishing up on air. Clear? So our focus areas will be, look, as a water. Now let's have a little bit of chemistry into it. Water is a compound. So one molecule of water contains what? Two atoms of hydrogen and one atom of oxygen chemically combined together. H2O. What is the molecular mass? 18. 16 comes from oxygen and 2 of hydrogen. 1 makes it 18. 18 atomic mass unit. Water. Before understanding pure water, please don't relate this purity in terms of what you drink pure. We are going to talk pure in terms of chemistry. So in chemistry, substances are comprising of two types: pure, impure. What is pure? A pure is a molecule, a substance which is made up of only one type of particle. So an element and a compound are said to be pure. Anything which has more than one type of particle, that is known as a mixture or impure, right? Like milk. You drink it every day for your health, but in chemistry we call milk as an impure substance because milk is a mixture. Whereas potassium cyanide, the moment you gulp it, you become photo. And every year we'll be replacing the garland on that photo. So that is considered to be pure. Now, when we talk about water in chemistry as a pure substance means H2O. But all the water that are getting around all across, from whatever source it may be, is it H2O or H2O plus something? Please. No, nowadays I never get angry. I've started laughing therapy. Haha. Please have a seat. Give us 2 minutes. We have one guest today. Ahri is missing you like anything on online today. No more chats, no more messages. Yeah, don't tell me that. Ahiri, your partner is live here. But she knows that. We don't chat.
In school.
In school. So our focus areas will be what is the difference between pure water and water from natural sources. Like if you're getting a water from lake or water from say ocean or a water from stream or a water from glacier, what is the difference between those? Now, the second is once a substance is dissolved in a pure substance, the pure substance becomes impure. As simple as that. Again, not from drinking perspective, from chemistry's perspective. Now, is every impurity bad for us? Some impurities may be good for us also, and some impurities may be harmful for us. So we're going to dive on that. How is water purified? This is one cycle that we will see. Then fertilizers. And the last two questions we will not attend today because they are for our portions for the next class. That belongs to air. Are we fine? Right? So we go one step more. The first thing we should understand is the water cycle. I hope all of you have undergone and seen what is water cycle from days. Okay, what happens? You have got many water bodies on the earth. So water gets evaporated. How many ways does water get evaporated? One is if you are a kiddo, you will only say water gets evaporated due to sunlight and the temperature of the water body going up. There's one more action called transpiration. Transpiration is when plants are releasing the water. Then we breathe. Respiration. As we are growing up, we should understand other ways also. Like we breathe. We are giving out carbon dioxide and water vapor. Moisture increases. Humidity increases when there are more people. So respiration is also one. And burning of fuels. Look at the burning of any hydrocarbon. Methane burns in oxygen to give you what? Carbon dioxide and water vapor. So these are all the ways that the water is going up. And the water goes up, condenses and forms tiny droplets. These tiny droplets are then flown away by air currents when they form clouds. And then when the clouds become very heavy, what they do? They pour back as rainfall. That's what we know. Okay. And that's why the water circulates. Two things that you should also know, something called percolation. Okay. Just a minute. Percolation is a new word that you'll see out here. Okay, so percolation means it is the process by which water moves through the soil into the groundwater system. All that you do, rainwater harvesting and everything that you talk about now, it's all about percolation. Now, suppose you have a water body, and from that water body, water has gone into the ground, and how it goes into the underground water level. That's called percolation. Dekho to, is anything that you don't understand here? I think evaporation you understand, transpiration you understand, percolation you understand. Like, so it's basically a cycle: evaporation, transpiration, respiration, and combustion of fuels. They will make all the water get converted to water vapor, go up, get condensed, tiny droplets with air currents become cloud, clouds become heavy, they come down as rainfall, so they add back to the water on the water bodies, and sometimes some of the water also seeps into the ground, which is known as the process of percolation, in which the underground water level improves, which is a very common problem. Like in Hyderabad, we say so much of construction has happened, so many people are dwelling now, the underground water level has gone down. Unless the rainwater or the rainfall is good enough and a lot of percolation does not take place, the underwater water table does not improve. I hope no doubt in this one also. Right. Ashmita, all okay? This is, I'll give you this PPT, so don't worry. This is from your textbook only. Right. So don't try reading everything. We'll discuss each points and understand. First of all, let's understand some properties of water. Whatever is important from the exam perspective, I'll tell you. So water is a neutral substance. Now, neutral means we'll revise some previous topics also. Metal oxides are always basic. Non-metal oxides can be acidic or neutral. This is a perfect example of a non-metal neutral oxide, dihydrogen oxide. So this is neutral. And when the pressure is 1 atmosphere, water will always boil at 100 degrees centigrade. So if I give you a sample of pure water, how do you find that it is pure water? If the pressure is 1 atmosphere, then this water should boil at 100 degrees centigrade and should freeze at 0 degree centigrade. Why? Again, remember what is boiling? Boiling is the temperature at which 100% of liquid converts into 100% gas at constant pressure. So boiling is a constant pressure process. Freezing is also a constant pressure process, right? Now, the second part is water is a very good solvent. Like in Hindi, there is a saying, "Pani mein sab dhul jayega." Water is a universal solvent. Now, this is one property for which you are never going to get pure water, because through whatever thing it crosses, it will try to absorb that thing and that thing will get mixed into it. Therefore, you thinking that I'll get pure water in this planet, on this planet Earth, is actually difficult, because it's a very good solvent. The moment it crosses any chemical, there is 100% chances that some percentage of it might be, and it's not about any chemical in the form of solid, liquid, even gases. You can even, gases also get dissolved in water. That's how fishes are alive. Otherwise, our fish is alive. Oxygen is there in what you call water also. Sinika, all okay? Somehow we were looking very vague, so I thought all okay, right? So because water is a good solvent, it dissolves many substances. It's present of these impurities that cause a change in the boiling point of water. Now, let's say we don't have pure water. We have water which is there in our house, our kitchen water. Our kitchen water, obviously, this is untreated water. This is not the water that you're getting from your RO. Even the RO has a lot of chemicals inside it. You take that water, think that it is some sort of close to pure water sample. Start boiling that water. Typically, if you guys make noodles at home, Hakka noodles. So when we make Hakka noodles, what do? We make the water come to boil, and then we'll add some salt and also some oil so that the noodles don't stick to each other. The moment you add salt, you will see that the boiling of the water immediately stops. Means now the boiling point has been raised further. So whenever you put impurities, the boiling point will also go up, the freezing point will also go down. Have you understood? The freezing point will also go down. So what is the solution for it? In laboratory and all, when we need pure water, we look for what is known as distilled water. Now, distilled water is not heavy water. Water is H2O. Heavy water is deuterium dioxide. That is one which we use in atomic power plants. Distilled water is pure water. The one that we use for filling up those batteries, the inverter batteries, okay? Inside inverter batteries, we always need distilled water to be filled up, car batteries. Distilled water is absolutely pure. This only we use for lab experiments. Neither you can drink it, nor there will be any, it will be good for your health also if you try to drink distilled water, because it doesn't have those, what is micronutrient and macronutrient. Macro are the ones which the body requires in more amount, carbohydrates, fat, starch. Micro are like minerals, like we need calcium. No, we can't eat that much of calcium, iron. These are called micro. So distilled water does not have these micronutrients. So distilled water is only for lab perspective. This is pure water. Understood? Now, these two lines which I have written is utmost important for your exam. This question comes a lot in 1 mark, and it may not come from this chapter. How to detect whether a given liquid contains water or not. Now, try to understand what I'm saying. If I take out water from my kitchen tap right now, as a student of chemistry, is it water? No. It's a impure substance. It's a mixture that I'm taking out, which is close to water. Water means only distilled water. Now, that particular thing which I have taken up from my kitchen tap, does it contain water? Yes, it contains water and some impurities also. How to test? The first way is take anhydrous copper sulfate. Now, first understand the chemistry behind it. Okay, copper sulfate is copper sulfate. Understand the chemistry and then everything will be easy for you. Copper sulfate is CuSO4. This is called anhydrous. Anhydrous means it does not contain any water molecule with it. Anhydrous salts are all colorless. The moment we add water to it, it is called hydrated copper sulfate crystal, which will be CuSO4.5H2O. Means with each molecule of copper sulfate, 5 molecules of water will be there. This is called hydrated copper sulfate. This is colored. Now we want to test whether a liquid contains water or not. So what we will take anhydrous copper sulfate, which is white in color, and we'll take a dropper, pick up the liquid and add 2-3 drops of that that liquid on anhydrous copper sulfate. The moment it turns blue, means copper sulfate has extracted the water from there. So the given liquid contains water. Have you understood? 2-3 type of ATP questions come. One is, how do you say that the given sample is pure water? Well, if you have lab conditions, pure water. If you have lab conditions and you can maintain 1 atmosphere pressure, observe whether it freezes at 0 degree or it boils at 100 degree. If it is a mixture and we have a doubt whether there is water present in it or not, something like, say, dal. We have made dal. Dal contains water. So how to test it? Just put it on copper sulfate. It will turn blue. Turning blue means copper sulfate, anhydrous, has pulled up this water of hydration and has started to show color. One more test that we do in lab is called cobalt papers. Cobalt 4. This is the one. This is cobalt 4 chloride. This is a paper strip which is available in lab. And I've written it with pink in color because if you take this paper strip and if you touch it on any of that liquid which contains water, this is a very authentic test. It will 100% confirm that it is water. Cobalt 4 chloride. Again, you have learned about it in salts, acid-basis salts. All these are anhydrous salts, cobalt 4 chloride. Cobalt 4 chloride, when it takes in water of hydration, then it becomes colored. Colored salts are all hydrated salts. So this question, if not from this chapter, might be pulled up from the section of salts as an ATP question. Is this understood? Clear? No doubt about this? Okay, you are able to see from this side. Okay. Now, so we understood about the test of water. Now, water may also be electrolyzed. This is what we understood in electrolysis. You remember, in electrolysis, we electrolyze water, but water is neutral. How do you electrolyze water? By putting some acid into it and making it acidic. Otherwise, it will not undergo electrolysis. Once it undergoes electrolysis, 2 gases are evolved, hydrogen and oxygen. Hydrogen is in 2 parts, oxygen is in 1 part. Hydrogen is the +1, so it will go to the negative electrode, which is cathode. And so there, what they have written here, when this is done, the ratio of volume of gas produced at cathode is twice. So what is produced at cathode? Hydrogen. Hydrogen is plus. Plus will always run to the negative electrode. And negative is who? Hydroxide, OH. So oxygen will run towards the positive side. Clear? This is basically a summary of what we have studied. The next one, unique properties of water. Here we will spend some time. The first one is water has an unusually high boiling point. Okay, the first one, try to understand. Let's talk about the molecular mass of 1 molecule of water. How much is it? 18 atomic mass unit. Agreed? For a compound to have 18 atomic mass unit means this is relatively very light compound, very light compound. If you compare it with, say, sulfuric acid and other things which are 98, calcium carbonate is at 100. This is a very light compound, but it shows a boiling point of 100 degrees centigrade. Quite unusual. So we are talking about unusual properties. This is one thing which is unusual. Okay. The next one, water has a very high specific capacity of heat. Recall your thermal physics classes. What is specific heat? The amount of heat required to raise the temperature of 1 kg of a substance by 1 degree centigrade. Water's specific heat is very high. It takes 4,200 calories, right? 4200. That's where 1 joule is equal to 4.18 calorie. The exact answer is 4180. So 4,200 calories is the amount of heat that you need to give to raise the temperature of water by 1 degree centigrade. That's why water can keep on absorbing heat. So all the hot water bags that we use for compaction and other thing, what do we use? We use water, because water needs a lot of heat. So that must mean the water, that means if I take a hot water bag in which I have put water at say 80 degree, 80 will be too hot, 60, 70 degree, 70 degree, the tap water was at what temperature? Might be 27. So from 27, you raise the temperature of the water to how much? 70. Enormous amount of heat it has taken in. So it will take a long time for that substance to cool down. Therefore, in winter places, if you have grandparents or someone, when they take the hot water bag at night, by the time it becomes morning, the bag is still warm. Whereas other things will not absorb that much amount of. Similarly, like when you have a glass of Bournvita, my very common example, if you just put it on a tumbler of water, water can aram se eat heat. But the water will not get warm, but your Bournvita will cool down because water is keeping on. Because the impact of rise in temperature in water is very, very slow. That's also an unusual property. Okay. The third one is its density increases when it freezes. Okay, this is very interesting. This point, which we know as, is known as anomalous expansion of water. Anomalous expansion of water. Very interesting stuff. What does it mean? Okay. If I take a substance and I start cooling it down, what should be the impact on volume? If you cool a substance, what should be the volume? The volume should decrease. Like in ice cream, you're cooling, it should freeze, freeze, freeze. In the case of water, as you start cooling water, water's volume decreases, 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 decreases up to a temperature of 4 degrees centigrade. After 4 degrees centigrade, water's volume starts increasing. Very unusual. Now, what is the impact of this? So let's say, what is density? Density is mass per unit volume. Once you are cooling something beyond 4 degrees centigrade, the volume has started to go up. So what about the density? The density has started to go down. Means the substance has started to become lighter. That's the reason ice is lighter than water. If you see the density of water is 1000 kg per meter cube. And if you see the density of ice, this is 990 kg per meter cube. So when you put an ice cube on a glass of water, 1/10 of that ice cube will be always above water. And if you are somewhere in the Atlantic, the iceberg also floats with its tip above water. Now, what is the benefit of it? The entire aquatic life is surviving because of this. Imagine the Arctics. So in the Arctics, the temperature is falling. Temperature falls, or the Antarctic temperature falls. Once it comes beyond 4 degree, temperature is going to go down. And beyond 4 degree and later, ice will form. But as it comes below 4 degree, the volume increases. So whatever is the substance, the cold substance, what will it be? Ice only or flakes of ice, they'll become lighter and they float above. And do not allow freezing of the water below that layer. That's the reason aquatic plants and aquatic life is surviving in cold temperature. Okay, now if you want to do mischief at your home, take a glass bottle and fill it completely with water and put it in the ice box. So beyond 4 degree, ice water will expand. So the morning when you get up, the bottle will be cracked into 2 pieces. Therefore, you will never see any ice bottle filled up to the brim and kept in ice box. Maximum chances that it will break. Not only there, like small glasses which we use for drinking juice and other things, even if you fill it with water without the top, with the top exposed. You know, in glass, right, the bottom portion is always joint. Glass is the frustum and the bottom portion is joint. Means I have done this many times, it will just come out. Okay? So these are unusual properties. Have we understood this? Then another thing I want to cover that, although it is written as a part of your further reads, but some further reads are very interesting. I'll cover this. That is hydrogen bond. When you go to grade 11, this will be very important. Let's understand what is hydrogen bonding. Before hydrogen bonding, let's look at the bonding of what you call water. We have oxygen. How many valence electrons for oxygen? 6 valence electrons, right? So 1, 2, 3, 4, and then 5, and then 6. Understood? Need anything? 4,200 calories. See, the definition of 1 joule is equal to 4.184 calories. If you want to love physics, 1 joule is 4.184 calories. To make it more proper, they say 1 joule is around 4.2 calories. So how many calories you need? You need 4,200. 4,200 amount of calories you should give to water to raise the temperature of water by 1 degree centigrade. So that's the specific heat. 4184 ke aaspaas hai, we take it 4,200. Okay, this is oxygen, right? Now let's see the bonding of oxygen is bonding with whom? Hydrogen, right? Hydrogen. Now try and understand. So this is a bond and this is a bond. So if you look for hydrogen, hydrogen has got 2 electrons, hydrogen has got 2 electrons, and this oxygen has got how many? 8 electrons. So I'm making this diagram a little bit more interesting now. It's something like HOH, right? 108 degree around the bond angle will be. Now what is more interesting is that there are 2 pairs of what do you call? We call them as lone pair of electrons. These pair of electrons are called bonded pair. This is called lone pair. Now lone pair is very dangerous. Lone pairs are like the unmarried sisters of the husband who are staying at home just to create the life hell of the newly wedded wife. Nanad jisko bolte hai na, these are the unmarried sisters. They're going to make the life hell now. So let's see how they make the life hell. Now, when you share, this is a shared pair of electron. So I'm sharing this pen with Nidhi. Whenever she wants, she uses. Whenever I want, I use. Slowly rivalry creeps up. Who keeps it at home? Are you understanding? Yeah. Why will Nidhi take it to her home? Why not my home? So the same rivalry creeps up here also. These lone pairs start attracting the shared pairs towards themselves. This property is known as electronegativity. Electronegativity is the property of an atom to pull the shared pair of electron towards itself. So oxygen has got 2 lone pair of electrons. What they will do, they will try to pull this shared pair of electron towards itself. Now just try and understand. Out of this shared pair, 1 electron already belongs to oxygen. There's no point, no issues. But it's trying to bring the hydrogen's electron also towards itself. Got it? As a result, oxygen develops a partial negative charge on this side. Have you understood? Partial negative charge. You're no more neutral. You have pulled, and you have pulled an electron from this side also. So you get up a partial negative charge. Delta means this is small delta. And a partial positive charge will be on the hydrogens. Have you understood this or not? So what is electronegativity? A unique property of an atom due to which its lone pair of electrons have the ability to pull the shared pair of electron towards itself. As it pulls the shared pair of electrons towards itself, there is no harm that you pulled 1 electron of yourself. There's no issue. But you have pulled 1 electron of hydrogen also, thereby gaining a negative charge extra. And you're doing this on both the bonds. So you're getting 2 negative charges. And so both the hydrogens develop equivalent amount of positive charge. And then what we call that this particular molecule is now polar. Polar means polarized. Charge develop ho gaya hai. Please don't see that constituency. They are a polarized vote bank. They vote in the name of religion. They vote in the name of caste. Polarized. Ek tarfa ho gaya hai. So this has become polarized, one-sided. So later when you study about solubility, you will understand polar dissolves polar. Likes dissolves like. Okay. Polar. So this has become polar. Once you become polar, now let's say we have another water molecule out here. Okay, hydrogen and hydrogen. So this is also delta negative, sorry, delta positive. This is delta positive. You have delta negative out here, delta negative out here. A small bonding starts developing out here between the plus and the minus. This is known as hydrogen bond. This is weak as compared to a covalent bond, but does matter when it comes to the structure of ice. I hope you know, if I throw pure ice on your forehead, you will have fracture. Ice is very, very hard. Ice is the hardest substance after diamond. In fact, from this 13th floor, if you drop 1 cube of ice on somebody's head on top, it will just, ice is like rock. Ice is very hard. If you fall on ice, fracture is inevitable. Ice has this hydrogen bonding. Later in this hydrogen bond also we'll see van der Waals force. As these are in grade 11, you'll see. So hydrogen bonding is weaker than what you call covalent bond. Hydrogen bond happens because the neutral molecule loses its neutrality and becomes polar. Polar means I develop some partial charges. So as a result, this oxygen gets, now this is entire sample of water. The next water molecule's hydrogen is getting attracted here. Similarly, this hydrogen will also be attracted here. This oxygen's delta will be with another hydrogen, and such is the bonding. So any type of a compound, like say methane. What is methane? CH4. So just look at methane. It has got 4 valence electrons. Who? Carbon has got 4 valence electrons. Hydrogen, 1 valence electron. Each of the 4 are married to 1 hydrogen. Is there any unmarried sister with the husband? No. Non-polar. Will there be any electron negativity? No. No electron negativity. Electron negativity will always be seen whenever there is lone pair. And in the series of electron negativity, we read it like FON. Fluorine is most electronegative. After that is oxygen. After that is nitrogen. May not be useful in this chapter, but sometimes in your chemistry career. FON. Fluorine, oxygen, nitrogen. Fluorine is highly electronegative. Possessive. I just don't want him to dance with anyone. Those videos is like that. Clear? Hydrogen bond. So this has nothing to do with volume. These are some unique properties of water. 3 of which are in your syllabus. One is a further read, but I found the further read is also interesting, so you should know. So what are the unusual things about water? That being a molecule of very small molecular mass, it exhibits a very high boiling point. Right? What is the next one? Has a very high specific heat. So it can, you can use water as an insulator. pH heat. The next one is what? Anomalous expansion of water, which is, you are seeing writing out here as decreases in density, but the better word for it is anomalous expansion of water. Why are aquatic lives possible in cold places? Due to the property of anomalous expansion of water. When it freezes in the Antarctic, the volume of water goes up. So the volume of water goes up means the density will come down. Water is no more liquid water at that time. It has formed what? Ice. Therefore, ice's density is less than that. You must have observed when you take any drink or something and you put a cube of ice, doesn't the ice cube float on it? Ice is lighter. That's why you'll see icebergs floating on top of water. And we say it's only the tip of the iceberg because only 1/10 of the iceberg you see. The entire thing is. So therefore, whenever we have any meeting, like which I've been trying with you all for last so many months. So what is introduction? We say breaking the iceberg. Breaking the iceberg. We see everybody just a tip, hi, hello. We don't know about other facets of you. So whenever there is a breakout session in any meeting, we say, go out, have some tea, coffee. There'll always be a networking session. All delegates have come, but they should talk to each other. So that's called breaking the iceberg. Clear? Understood? We'll go to the next one. Right. So now we need to understand about water pollution. So let's first discuss what is pollution. Simple definition. Okay, these are in books. Deterioration of the quality of a substance. What are we studying? Water. By actions, natural, which may be unforced, and by human, which are forced. तुम जानबूझ के कर रहे हो. And deteriorating the quality of that substance is known as pollution. If you deteriorate the environment, it is called environment pollution. If you deteriorate the quality of Noise, you call it noise pollution. If you deteriorate the quality of air, we call it air pollution. So in water, what we are doing, we're going to study about biological. What are biological? Biological pollutants can be like something like a dead body or a decayed, something like a plant and other things, which are biological. Okay, dead bodies are all biological. Okay, and then forest being washed away, or say some sort of carcinogenic plants are there which have been washed away. So they are known as biological, and chemical pollutants does not need any introduction to you guys. Anything that is chemical in nature and is harmful is known as a pollutant. Harmful for what? For water. Okay. Deteriorates the quality of our water. Now, lack of the availability of fresh water leads to waterborne diseases. Therefore, we say whenever floods happen, immediately after flood, the first thing which is going to happen and doctors are most worried about is the spread of epidemic. I hope cholera nowadays we have control, but cholera is also a bacteria. You know what is the bacteria for typhoid? Anyone? Bio, Salmonella typhoid. Have you heard? Yeah, Salmonella typhoid. And this one is I think with V, Vibrio cholerae. Yeah, Vibrio cholerae. Salmonella typhoid. Typhoids, only way typhoid can come is whenever there is any chances of human feces or human waste that has come in contact. That's the only way typhoid can happen. Please understand. That's why if you go to Mumbai and Maharashtra, there is a common practice that people will not eat any green leafy vegetables during the onset of monsoons. That's why they say रास्ते का ये सब गोलगप्पा गोलगप्पा खाने मना करते हैं ना, हाथ में गंदगी रहेगा कहीं से भी. Salmonella typhi is present in human feces. So that's, if that comes in contact, 100% assured you will have typhoid. And cholera, the outbreak is very common because once it is flood and flood has entered your house and you don't have, say, the flood water level is more than your Western toilet or your Indian toilet, it's equivalent of urinating anywhere rather than going to the toilet, because every water has now mixed, and cholera will happen. This is the biggest problem: cholera, typhoid, and then diarrhea. I hope you know what is diarrhea also, right? Now, pollution is a modification. This is your book statement that takes place to the environment. It's a modification. Now, every time it's not that we are polluting the environment because we are not aware of it, but we are bound to. We as a country in India, we are so highly populated. We want agriculture to give us returns much more quickly. Like I'll tell you my childhood, when I used to go to shop for vegetable shopping, I have never seen a cauliflower in the month of June. Not possible. So when winters used to come, we used to say, now the good vegetables will come out. And the shopkeepers used to keep white cauliflowers with red tomatoes, green chilies. Winter vegetable market was very exotic. And coriander, I'm not bluffing. If somebody chops coriander kitchen out here, you will smell from here. And if the next door neighbor lady has just put coriander leaves on her curry, you can smell it till here. Now coriander, if I just make it like this and make you smell, you still can't do it. So agricultural demand has gone up a lot, which means what? That it is not that your cultivation can only be restricted to lands which are worth for cultivation. I hope you know the high-tech city area out here. The high-tech city area is all terrain land, rocky. If possible, if nothing was there, why did they give it all for software and all? Because nothing can grow there. But with the use of fertilizers, we are making non-cultivable land also to give us output. We need it. Cycle time is reduced because so you get grapes throughout the year. Just imagine, grapes are available throughout the year. We never used to find grapes throughout the year in our childhood. Okay, ridge gourd. Ridge gourd is a summer vegetable. Ivy gourd is a summer vegetable. Okay, now pollution is a modification. That's why it's a better word. It's a modification that takes place to the environment, that can be water or air, caused by human influence by releasing substances into our water or air. We have released it. Were we not aware while releasing? Yes, we were aware. We're helpless. इतना चाहिए खाना, कहाँ से लाएंगे इतना? Population is going up. Purchasing ability has gone up. People want food every day. Where do you get it? Not possible. So let's try to understand the water pollution in this diagram. Water comes through the atmosphere to the earth's surface. So every wrong thing that will happen which leads to pollution has to happen in this journey. Is this understood? So this way you will understand, and the entire PPT I'll give you, don't worry. So water goes from the water that is coming from the natural resource, like say rainfall, goes to the atmosphere and then goes to the surface. Yehi uska journey hai. So whatever wrong things will happen here. And what are the wrong things? Number one, water is a very good solvent. Our son goes to the college hostel. He makes lot of friends, is very social. So once he is very social, there are two dangers. He will get lot of books and question paper, and he will have lot of distraction. So water is one such सा बहुत सारे दोस्त हैं उसके, है ना? आखिरी समझ में आया तो water has got very social, you know, so a lot of friends and all. So let's see what happens to water. So from the air, as water is coming down, let's say rainfall. So what do you have in the air? Maximum amount of nitrogen, carbon dioxide, and you have water. For the nitrogen ke saath, I will not take any such issue. Air absorbs carbon dioxide and oxygen. Anything that I'm writing in blue is bad. Okay. So what happens to oxygen? The oxygen is beneficial for the aquatic life. Water dissolves that oxygen. You know, I have heard about these things called BOD and COD, chemical oxygen demand and biological oxygen demand. You know, tank band in Hyderabad, Hussain Sagar Lake. Hussain Sagar Lake, you can't go fishing. There is no fish. You know that? Because it's all contaminated. So there is no oxygen level out there. As a result, fishes, in order for, say, many people bring what you call a aquarium and say, "Hamare yahan na machli mar jate, all our fishes die." You should be a little bit scientific. Hey, I was using RO water, I use Bisleri water. Nothing. If the water fish has to live, it will live in that tap water also. Probably you see how much is the oxygen demand for that breed of fish. And is your water having that much of dissolved oxygen or not? If not, the water fish will not live. As simple as that. Fishes are living even in Shadan Lake. Don't tell me that that is more pure than your tap water. All medical wastes are going there itself, right? So, if water absorbs oxygen, that is good for the aquatic life. But water is also dissolving carbon dioxide. Carbon dioxide is a gas. So, what are the sources? Always remember SOx, COX, and NOx. Oxides of sulfur, oxides of nitrogen, and oxides of carbon. They will mix with water to form what? Non-metal oxides react with water to form acids. Oxides of sulfur will give you sulfurous and sulfuric acid. Oxides of nitrogen will give you nitric acid. This is oxides of carbon, CO2. So it will give you carbonic acid, the acid which is there in your fizzy drinks, Thumbs Up and Pepsi and all. So this is making a low level natural acidity. It's a low level acidity. Itna harmful nahi hai. But you are using so much of carbon imprint, carbon fuels, all the petroleum products that you are burning, all the industries that they are burning, all the fuels, everything. So what are you releasing? Carbon dioxide into the atmosphere. If you release more carbon dioxide, then the water is going to absorb more carbon dioxide. So what was a low level natural acidity? Mr. Rajiv Rastogi now slowly becomes a threat for you. The water levels acidity is slightly picking up more. ये पानी पैदाइशी acid है. And then a good Bong or a Malayali will say, fishes are no more tasty out here. Because you're not getting the natural habitat taste. Like our parents will always say, nowadays these fishes don't taste at all. Even I myself say, the quality of fishes I had in my childhood, if I have it now, it's not there. Because same thing, right? So have you understood this? Okay. Now from the Earth's surface, when you have come here, from the Earth's surface, water absorbs nitrates. We will see it in the nitrogen cycle also. So nitrates. All the fertilizers that we use, the most common form of fertilizer is ammonium nitrate. Nitram as we call it. Ammonium nitrate. अच्छा, ammonium को थोड़ा देख लेते हैं. This is ammonia. NH3 is ammonia. If NH3 absorbs, like reacts with water, it picks up another hydrogen and becomes NH4 plus. Ammonium ion. Ammonium ion is the only non-metallic cation. Ammonium nitrate, NH4, NO3. NO3 is minus, NH4 is plus. This is ammonium nitrate. This is the most common fertilizer any farmer will use. Most common. So this nitrate, now we will see why is the farmer using this ammonium nitrate? इसनी क्या जरूरत थी? जरूरत है. जरूरत तो है. And we will not only say that, you know, we need more production. No, we will see what is the reason for that. So this nitrate is there, which is on the Earth's surface. While it is good for the growth of the plant, the problem is that when it is getting washed off. So ammonium nitrate, similarly, we have got another ion called phosphate, PO4, 3 minus, H3PO4. So we have ammonium phosphate also, NH4, 3, PO4. 3 of this mixes with that, right? Ammonium phosphate. So nitrates and phosphates from agricultural waste. And phosphates and nitrates are also present in your detergents. That's why we say detergents are not biodegradable. You should not take Ariel and start washing it on the river or the lake. Detergents are not biodegradable. So they are getting inside it. Chemical fertilizers are washed off from the surrounding land, washed off from surrounding land. A lot of rainfall happened. So there was a lot of fertilizer. She was a farmer. She used a lot of fertilizer and her terrain is like this. So it has washed off all the fertilizer and they have gone and poured into the water body. So the water body has now become rich in what? Nitrate, something that the water body does not want. It was something that the soil wanted, but it went to the water, and phosphate. And plus they also wash all their clothes. Now, another thing that you should understand is industries, like if I'm a beverage industry or if I'm a processing industry, whatever I don't use has to be processed and released. That's called effluent. In any plant, if you go LPG plant, refinery, or a tire manufacturing plant, anything which is a manufacturing company, you'll always hear about a division called, where is Dhruv posted? Oh, he's in charge of ETP, effluent treatment plant. So the effluent cannot be released just like that. You have to make it environment friendly. So if the effluent is having a lot of these unwanted things, so if you are a chemical industry, 100% these will go inside. So in Bombay, like if you go to Maharashtra, Maharashtra has got these bodies called IDC, MIDC, Maharashtra Industrial Development Corporation. You have that in Nagpur, you have in Nasik. In Bombay, we have like places like Taloja. And if you go there, it's all factories, all factories. So imagine what will be the water condition out there. Now let's put the example now in Hyderabad. If you know the geography of Hyderabad, we have a place called Patancheru. Patancheru is very rich in arsenic. Arsenic is highly cancerous. Why arsenic? Because once upon a time, what is Miapur area now, which you see, it used to have all the good industries of Hyderabad, HMT, Alwyn. Kukatpalli was all Alwyn. If you talk to your parents, they will say Alwyn. Even the bus stop name is still Alwyn. Then all pharmaceutical companies, they were all on Bombay Pune Road. So Bombay Pune highway means they're all under Miapur Chandanagar Road. So and Patancheru, they used to be all industrial belt and more of pharmaceuticals. So Patancheru average level of arsenic is very high. Water is not at all potable. Arsenic means cancer. But again, flats and flats are being constructed. We ourselves are not worried about. We will think twice about cost of flat, quality of flat. But where have we constructed? Pani to wahin se uthega na. Right, chemical fertilizers washed off. Artificial fertilizers such as ammonium nitrate, as I told you, and ammonium phosphate, as well as some pesticides. All these are getting washed off. So it's deterioration. Detergents used in the home and industry contain phosphate. Nitrates and phosphate encourage the growth of algae. Now this is another problem. This is known as deoxygenation. These nitrates and phosphates, what is the harm if they get into the water? Once they get into the water, they are going to create the growth of some algae. And these algae will eventually die and decay. So once you decay, you are a bio-waste. And by the time you died, you ate up a lot of oxygen from the water. Are you understanding? Parasite jaisa. You know what is a parasite, right? A parasite will always come on a host and eat the host. Lice is a parasite. So these algae are going to eat up the oxygen and they will themselves also die. Zinda raha tab bhi kharab hai, and after death also they are bad. And that is known as deoxygenation. So they can also disrupt the sensitive ecosystem. So these are two aspects. We have not yet handled the industry part. So first part, what did we understand? We understood about oxygen and carbon dioxide. The second one was all about fertilizers. We're going to discuss fertilizers today itself. So ammonium nitrate, ammonium phosphate. Detergents also give you phosphate. And when they get washed off in water, they are giving birth to a lot of algae. These algae are going to breathe in this oxygen and then they will die. Ultimately, they will deplete the oxygen, known as deoxygenation. Story hai pura chapter. Aye, next. Metal compounds. This is what the Hyderabad example which I was giving, Patancheru. Metal compounds from industrial wastewater. What is the type of water? Specifically battery industry, acid industry. The type of waste that you are throwing out. Is that waste? Pollution control boards have now very strict norms. If they check your waste output and the waste output is not complying, that means you are releasing toxin into the environment. Not at all. Which may contain harmful chemicals such as mercury and cadmium. Both cancerous. Calcium containing compounds. Now another interesting thing, if you are a calcium containing compound written in yellow, I've written in yellow means it is good. So this will actually increase the presence of calcium, which is also needed as a micronutrient for your bones and teeth. So the water, if you go and have distilled water, you will say that, sir, your water doesn't have taste because you're habituated having this RO water, which has a blend of salts. So calcium is present there, magnesium is present there, which actually gives you the taste. So like Aquafina, Bisleri, are they mineral water? No, they are packaged drinking water. What is a mineral water? Himalaya. Himalaya's cost is more. Have you seen the Himalaya bottle? It will be purple, violet in color. Price is much more higher. That is mineral water. Once you gulp Himalaya and you gulp Bisleri, Bisleri is also, they are all pure. That's a packaged drinking water. Himalaya is a mineral water. So दाम ज़्यादा होगा उसका. But sometimes many people will say, no, this is tasting too much salty or something like that. Okay, electrol. How many of you have had electrol when you had stomach upset or something? The green packet, ORS, which we drink. Electrol. Have you drank it? It's actually very good. But you can't, if you're having noodles and all and you feel thirsty, if I give you electrol to drink, will you find the taste? Not at all. I'm not saying the orange one, the plain green, white colored salt. So it's having only sugar and salt in it. ORS. I hope you know how to prepare ORS if electrol is not there. 4 teaspoons of sugar, 1 teaspoon of salt in 1 liter of water. 4 by 1, that is your ORS. And plastic polluting streams. Plastics, you know, detrimental to aquatic life and all. Clear? Now let's see water filtration. एक बार इसको देख लो. Filtration is to be understood under this heading. Filtration and chlorination. Our first job will be to filter the water, and next job will be to chlorinate the water. Filter is to remove all impurities. Chlorination is to kill all the germs. Kirtan, what happened? Sleeping? What? Eyes are getting closed slowly? Maybe I'm boring. Acha, filtration, do you understand? Filtration is removing all impurities. Chlorination is sterilizing the water. So let's start, okay? Stage by stage. Generally, all the water supply body in any city will be supplying water from a mainstream lake. Manjira, all this as we say, is from a lake. So as you first get the water, your water is passed through a screen. Bitu, this whole thing will come as a slide to you, don't worry. Okay, and it is your typical textbook, the Glendu textbook. So don't worry. So water passes through a screen. Screen is like a sieve. You're going to block all unwanted, visibly large sort of impurities. Polythene, jo hai, sab atak gaya. And after that, the water is pumped and taken into a section where we will do 2 jobs. Understand? First is aluminum sulfate. Aluminum sulfate is what? Al2SO4 whole 3 24H2O. I hope you know this product. Al2SO4 whole 3. This is aluminum sulfate. I am writing 24H2O. This means this is called alum. In Hindi, we call it fitkari. Alum's best use is alum will take all the impurities and settle below. So if you find that there is some, if you go to any of your say relatives' house where they have their own bore water system, so there will be a sump. Immediately they will remove it and see kitna pani hai niche. There's a sump where the water comes and gets deposited. In that sump, to clean it, always add some alum. If you add alum, all the impurities will be pulled down. Once they have been pulled down, we use coarse sand as filter. This used to be in our hostel also. Coarse sand. Coarse means very rough sand. So sand is very rough. If you are rough, you will block the impurity and you will only allow water to go through. Coarse sand. Have you understood? Mote. And many people use pebbles also out here. Acha, how many of you have seen a small aquariums? I'm saying this one. Have you seen a lot of pebbles we put? Many people don't put pebbles, they put sand. The main thing is that because the aquarium which we have in house, it's a studio apartment for the fish. He eats there, he or she. It's 3S. Shit, shower, shave. Everything is happening in that tank itself. Don't you agree? So everything has to be absorbed. So the pebbles absorb, and when you clean it, since we had it, I know, once you start cleaning it, you just remove the pebbles and you'll see a whole colloid of dust products coming out, waste products coming out. So coarse filter is going to block it. Clear? After that, it comes to something known as a sedimentation tank. Here the impurities will be in colloidal. What is colloid? If you pass it through a filter paper, the impurity will pass through. Colloid, like milk is a colloid. The dust particles are absolutely mixed in it. So what we say flocculants. Flocculant is again aluminum sulfate. It's also the same thing. Once again, it will be dropped. And now what we will do, the flocculants, the aluminum sulfate will again take, aluminum sulfate is very clever. Any small amount of granular impurity, my boy is very good. He makes a lot of friends. He makes a lot of friends. And it will sediment. You'll allow it to sediment. So you just take out the top part. Now the top part goes and gets into another one. Now here what happens, we will have fine filter sand. See, it's all the job of filtration going on. Our job is as much as impurity that you can trace out. Big ones, little bit smaller ones, extreme smaller ones, and then it goes to carbon slurry. Carbon slurry, okay. Have you seen your ROs in your house? The RO water, the pipe will come and there will be a white color vertical one vessel. That's called a pre-sediment filter, usually called a carbon filter. If you open it, there will be a cartridge which has nothing but charcoal inside. Madam, aapka carbon filter jam khatam ho gaya. Charcoal. Charcoal, you know, wood burnt and then dried. So charcoal, what it does, it will remove immediately all the smells and odor. Okay. Srinika, they had gone for 3 or 4 days to Calcutta recently. If they would have gone for 10 or 15 days more and say you switch off your refrigerator will start developing a smell, which is very common. How to kill the smell? Once you start back your refrigerator, put a cut piece of lemon or a piece of charcoal. Charcoal will take out all odor. Same funda. That's why I always say chemistry begins in your kitchen. Charcoal will take away all your tastes and odors, whatever odor was there with this. And what we are going to do, if the water is little bit acidic, we will add lime slurry, calcium oxide mixed with water. Lime reduces acidity. Our job is to make the water filtered, tasteless, odorless, neutral, so that we are able to drink it. Fine. But still, it has now come to the next stage. At this stage, filtration ends. Chlorination starts. Why are you adding chlorine? To kill all the germs. But again, a problem. If you add chlorine, you are going to increase the acidity level. So add sodium hydroxide. Base, it is going to kill the acid. So base, it will take out all the acids from it. Okay. And still what happens, if there's still some acid after storage tank, somebody still pushes a little bit of what you call sulfur dioxide, SO2. Sulfur dioxide will take away the chlorine part. Achha, have you drank water, some places like municipal water and all? Have you smelled chlorine water? Like in some swimming pools, the day chlorination happens. So if you go to some tap water in school or somewhere, some places you'll find, you can judge the smell of chlorine. That chlorine smell came because adequate amount of sulfur dioxide was. Sulfur dioxide will neutralize the chlorine effect. And then for more better parts, क्या आपके toothpaste में नमक है? Fluorides. So fluorides are also added to prevent tooth decay. Filtration. Massive debris gone. Miniature debris through aluminum sulfate. Aluminum sulfate gone, then sedimentation. Colloidal debris are also taken care of out here. Then only the top portion is taken. Pre-carbon or carbon slurries to take away odor and taste related issues. And then what we will do, we'll inject some bit of lime. Now these are all case based. If the water is acidic, inject lime, make it neutral. Now filtration done. It is not yet clean. So to clean it, what we do? Chlorination. And what are we doing in our RO? Our RO does not have a chlorine plant. So how is the filtration being done? Filtration is all right. RO has got 4 stages. There are 4 filters and plus 1 pre-carbon. After that, filtered. After filtration, how does the RO clean? UV. Naya Kent RO UV filter system. UV, ultraviolet rays. Ultraviolet is used for cleaning germs. Have you gone to a salon or other place? Where do they keep their scissors and everything? In that violet ray enabled. Or if you go to the operation theater, or then everything is kept under ultraviolet. All our these things have got ultraviolet. They don't have chlorination. RO plants have got all ultraviolet systems. That is how they clean it. And then there will be the most costly, which they call as the silver cartridge, which is going to punch those minerals which give you taste. See, if you are a student of science, like when I replace those cartridge at my home, I will first taste the water before the silver cartridge and taste it after the cartridge. You will tell the difference. Before the cartridge, it is very bland. Nahi maroge aap. Bland means tasteless. Bland. Bland, you say, na, sometimes you have bought some oranges, neither they are sour nor they are sweet. Bland taste. All understood? Shall we go to the next part? Fertilizers. Fertilizer, Why do you need fertilizer? We have spoken about that. Now, please understand, I have got lands which are good for cultivation. I have got lands which are not fit for cultivation. Don't go there. No, sir. The demand is such, the profitability is such that we will have to go there also. We will have to go there. And if you want to go there, then you need the soil to be made fertile. What is making the soil fertile? The first thing, understand, making the soil fertile is to fix the nitrogen issue in the soil. The soil needs nitrogen. In what format? Nitrate. Soil cannot, you can't take a cylinder of nitrogen and blow it into the soil. The soil needs it in the form of nitrates. Now, are we getting all the nitrates possible? Now, just imagine, what is the atmosphere having? Hydrogen and nitrogen. So, whenever lightning happens, what did we study? Nitrogen monoxide formation takes place, right? That happens in gas chambers also, sorry, in combustion chambers of engines also. In lightning, nitration fixation can happen, but that is much more rare. Another way, try to understand, if I have a stock which is grown, like say paddy, and you have harvested it, so the entire nitrate part is taken away from the soil. Try to understand what I'm saying. This is a grown plant, sugarcane, and I have uprooted the sugarcane and I have taken away, the nitrate part goes away with the plant. If that cultivation was allowed to decay on that particular soil itself, then the nitrate would have remained in the soil. But are you an idiot farmer that you will allow your crop to decay? So nitrates have been washed away, taken away by you. Are you understanding? You have taken away the nitrates from it. And so the question arises, the amount of nitrates that we need is not being fulfilled by that natural process of lightning, nor the amount of plants or the crops that are naturally decaying. We need more, even for the natural, or even for the good ones. So what is the source? Fertilizers. That we will see as a part of nitrogen cycle also. So here there is a process in your book which will be written as Haber's process. We will read this in chemical equilibrium. Let's just understand what is Haber's process. Haber's process is the process to make ammonia. So what Fritz Haber, so what he does, N2 plus H2 will give you NH3, right? So NH3 means, so N2, 2NH3. This is Haber's process, roundabout, if I'm not wrong, 200 ATA is the pressure and roundabout 400 Kelvin is the temperature. We'll study this in chemical equilibrium. This is the industrial process of manufacturing ammonia. While this ammonia is manufactured in a plant, they also manufacture what is known as nitric acid. Ammonia reacts with nitric acid to give you ammonium nitrate, also known as nitram. Nitram, am from ammonia, nitram. Most common fertilizer. If you go to a shop and say, plants are not growing rows, I've got rows, ye dal dijiye, all are ammonium nitrate. Fertilizers which add nutrient to the soil are three classes of fertilizers. We call them as NPK. N is supposed to fix nitrogen, P is supposed to give you phosphorus, K is supposed to give you potassium. And the way we remember, sometimes they ask you, Ng, always remember, Ng, nitrogen for green foliage. So if you want a lot of palak, spinach and other green herbs, don't go like an idiot and you put some, phosphorus oriented fertilizer. You should put fertilizers which are rich in nitrogen. So one of the way is buy NPK. NPKs are available in various ratios. NPK is one blend. So in NPK, you can get this more, this less, this more. This is what is the art of farming. Let's say if you're having hibiscus needs strong roots. So you should be stressing more on potassium. Kg class, potassium for growth. Ng, Kg. This Ng is for green foliage, or NF as you say. And this is PR, potassium for roots. Okay, some of the fertilizers, ammonium nitrate, ammonium phosphate, and urea. I'll show you when we come to what you call this chapter of organic chemistry. This is called a carbonyl group. Carbon has 4 valencies. 2 are tied up with oxygen. Oxygen satisfied, carbon both open. So on one side you have got NH2, on one side another NH2. Urea's invention in lab made person realize that organic substances are not which God gives you. Urea is a major constituent of your urine also, right? So in fact, I'll share it some other day about this. I don't know whether you have knowledge. All the BS6 diesel vehicles which you get nowadays, BS6 diesel vehicles, there are two tanks if you have seen. There is one tank which will be for diesel. There's another entry called AdBlue. They need AdBlue also. AdBlue is nothing but urea. Urea dissolved in water is AdBlue, because diesel has got a lot of nitrogen in it. So a lot of nitrates will be created. This will absorb it, all nitrous oxides and other harmful gases. We are not allowed to release that as per BS6 standards or Euro 6. Like Scorpio N. Scorpio N has got two outlets. One is for diesel, one is for AdBlue. So AdBlue is nothing but urea. Okay. Understood? So let's have a quick look at the nitrogen cycle. This is what I was saying. So all these shows you how nitrogen goes inside. Nitrogen in the air. So we know by lightning and all, it can go inside. Fertilizers produced by Haber process. Nitrogen fixation. I hope in biology you have read that there is a bacteria called rhizobium bacteria in the root nodules of leguminous plants like peas. Pea, mutter. Pea is a leguminous plant, climber. So there is a bacteria called rhizobium. If you grow mixed cropping, you know what is mixed cropping? When you grow two type of crops in which you retain the nutrient. So if you will see dal grown with mutter. So rhizobium bacteria will fix the nitrogen. But these are not doing that much as we need. So this is again getting nitrogen back. And this plant, when it dies, decay, it will also fix, right? Then nitrogens from the roots of the plant goes, this is nitrate. Remains of dead plants, excreted waste. However, plants also use lots to make proteins. These rhizobium bacteria, when they fix nitrogen, they're used for making proteins. So some of the nitrates you have taken, and rest you have cultivated and hybrid after harvesting you have taken away with them. So there is a deficit of nitrates. So nitrogen fixation should take place. The only way that you can fix is through fertilizers. We are helpless. But the issue is when this fertilizer is getting washed away. So going further, leave this part. Let's come with this. Problems with fertilizers. If you are using too much of fertilizers to the land, now this is no more rocket science for us. Rain washes off the fertilizer from the land and then it to the river. And this process, this name you should know, is known as leaching. Leaching is the process in which excess fertilizer is washed off from the land by rains and the fertilizer is allowed to enter inside the water stream. You'll get this, don't worry. Leaching gives rise to another thing called eutrophication. Eutrophication. Now let's understand what is eutrophication. This you have already studied actually. Eutrophication means the algae, the nitrates and the phosphate which go into the water, the algae will multiply rapidly, causing the water to turn green. Ponds, water turns green. And then as the algae die and decay, right, oxygen is removed from the water, leaving insufficient amount. So now the water has the biological demand, BOD, biological oxygen demand of that water has reduced substantially. Therefore, the aquatic life will no more survive. And a bong fisherman will say, that breed of fish now no more grows in this pond. Why? Because that breed of fish might be needing more oxygen, which due to the excessive farming of modern technique farming, this has gone bad. And there are also worries about agricultural fertilizers, specifically ammonium nitrate on public water supply. As I say, the water table, the water that you are getting, the hardness level of our water, I had once furnished some findings also. Like in US and all, they'll say when 500 is beyond, if you just take the water from your, tap water from pebble, from the ground water system, hardness level is straight away much more than 576, 670. Okay, so now you have to bring down the hardness level. But hardness is a different thing because it's salt. But if you are getting unwanted things getting inside it, then we are into real problem. A type of numerical, which if comes is you're very lucky, very interesting one comes is, what is the percentage of each element in a fertilizer? Let us just understand. 1 minute, don't look at the numerical, look at me. What is the percentage of each commodity in making a cake? To make 1 kg cake, I need say 10 grams sugar. So what is sugar's percentage? 10 gram divided by 1000 into 100. So similarly, say suppose they have given you NH4 to SO4, ammonium sulfate. Find its molecular mass, all the data will be given to you. So the molecular mass of ammonium sulfate is blah, 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 132. And we want to find out what is the percentage of nitrogen. So how many nitrogen are there, beta? 2 nitrogen. Each nitrogen is 14. 2 nitrogen makes it 28. 28 upon 132 divided into 100. That way you should find out. And overall, if you add up everyone, you'll find it as 100%. This is a question which comes. So if this question comes, you are very lucky. That's all. We're on time. So I'll share this one with you so that you get it as a